how to calculate intersection of two functions. Actually, the principle is quite easy, but I know many students have problem with this. So the trick how to do it is you take both functions and you equal them, right? So I demonstrated that. So you have something here, that's your first function, and you have another function here, second function. And the way how to solve this, how to get the intersection is just set them equal, right? And then you calculate the x and you solve for x. So you just arrange all the terms from left to right, right to left, until you end up with x is 5 or something like this. Or maybe 5 is 5 can also be, or 5 is 3. And how it works in detail, I will explain you in the following video. I'm going to show you how to calculate the intersection of two functions, and everything you have to know is the following. You have to equate the two functions, right? Okay, this is what you have to memorize. And when I learned it the first time, I also had trouble to imagine it, how to calculate it, and so I had trouble with the first homework, and I couldn't do it because I just didn't know how to do it. But it's actually so easy. So I'm just going to introduce the principle to you, how it works. So y-axis, x-axis, and we have two functions. First one is, in this case, two linear functions. So this I call f, the other one I call g, and when you want to calculate the intersection, it is very easy. So x1, and you just call it x1, y1, and the intersection point we call maybe I, and the coordinates would be x1, y1. It's so easy actually. So, as I said, the principle is equate the two functions, equate f and g. And I'm going to show this with an example. So we have f is minus x minus 10. G is 10x plus 1. Two functions are given. The question is, where is their intersection, or is there any intersection? And how to calculate, as I said, first sentence, you have to equate f and g. So that's exactly what we are going to do. We have to equate f and g. So f is supposed to be the same as g. If it is, we don't know yet, but it is supposed to be the same. We just assume this and see what's going to happen. So just let's calculate it. Minus x minus 10 is 10x plus 1. What are we going to do? Minus 10x, so the x to the left side. It's minus 11x is minus 10 is 1 plus 10 is minus 11x is 11. Looks good, almost. And divide by minus 11 so that we can isolate the x. So if x is 11 divided by minus 11, then we can write also minus 1. So we found a value for x where the two functions are the same. So this is good, so we found the intersection. But we may also want to know the point actually, so we want to know the value for y, how to get this. Now it doesn't really matter where we put in the minus 1, either in f or in g. The result should always be the same, and I'm also going to show you that it doesn't really matter. So in an exam, when you're in a hurry and you don't want to make big mistakes, you just put in the x value in the function where you have the impression that the calculation would be easier. This is how you do it in an exam. But now I'm just going to show you that the result, wherever you put in the minus 1, will be the same. I hope so. So so we just put in minus 1. So minus 1 minus 10 is 1 minus 10 is minus 9. G of minus 1 is 10 times minus 1 plus 1 is minus 10 plus 1 is minus 9. So I demonstrated the result is the same. Of course, we wanted to know where, because this was already our assumption, right? That the result is the same at one x value. Then we got the x value, and of course if we insert it again in the function, then it is the same, should be. Otherwise you made a mistake. The thing is, in this calculation part, it might also happen that the result is not x equals minus 1, but it could be, for example, the result is 5 equals 5. That's possible. It could also be that the result is 5 equals 6. Of course, this is rubbish. And this would be okay, but then you don't know the x value, right? What is intersection? I'm just going, because students are always confused about those two cases. And of course, when I learned it the first time, I was also terribly confused about it. But it's so easy, and teachers mostly avoid to explain it. I don't know, I don't understand why they avoid those two cases. They just want to see the students get into trouble, but it's so easy. So we have function f and a function g. So those two functions are parallel, which means that they don't have an intersection. And so this case, so it doesn't have to be 5 equals 6 necessarily, it could also be 10 equals 15 or something. That's something where you have to say, okay, this is never true, never. So it says that assumed that f equals g, it is never true if something like this comes out. So it can also be that we assume f equals g and the result is this. So it says our assumption is always true, always. So no matter what we insert, what we have, what kind of x value we have. And this means that it's also possible, right, that this is f and g at the same time. So f and g are actually the same function. This is possible. So that's this case. So we have a lot of intersection points, which is infinity. We have so because those two functions are the same, right? So in this case, no solution. And in this case, the functions, I don't know, depends on the question. You can say the functions lie on each other, or the functions have infinite intersection points, or something like that, right? But the functions are always the same. Okay, so this is how it works. Intersection of two functions. So just keep in mind, I would say this is the most important point. The special cases, of course, the two special cases I just introduced are also important, but the main thing, the first step is to equate f and g, and everything else then you calculate. And then, of course, when you have a result like this, it's very easy. You have an intersection point, which is, I didn't write it, but in this case it would be minus 1, minus 9. This is the point. If it's asked, if you have to give it as a solution. And those two special cases you should also keep in mind when you calculate it. So this is how it works. Thanks for watching. Practice makes perfect. Further exercises with solutions you can find on my website, which is www.worksheets.com.